All right, everyone. Thanks for joining us today for this lesson in distance learning. Today we're going to be doing 6.1 properties of exponents for the third day. All right. This one is going to be our last and final piece to the puzzle, and then we're going to combine them all and do these ridiculously crazy looking problems that actually are pretty easy and fall into place. All right. So far, just to recap, we've done problems that look like this: x squared times x to the 9th. That answer is x to the 11th. We've done problems that look like this: x squared to the 9th. That one's x to the 18th. Right? What's the difference? These ones you're multiplying. These ones you're adding. Okay? So don't forget how to do all that stuff, all right? Then we talked about, let's see, let's use green on this one. We did ones that looked like this: 3x squared y to the 5th. And on that one, we had, let's do it all to the 3rd power. And that one really distributed out to each piece. And you got 3 to the 3rd, which is 27, x to the 6th, y to the 15th. Okay, you see that? Then we started to add negatives and zeros. The x to the 0, that's super easy. Anything to the 0 power, right? Parker, what do you got for that one? X to the 0, it's going to be 1. Okay, nice work. Then we had the crazy looking negatives. X to the negative 8, okay? Or 2 to the negative 3. Or 5 to the negative 170, right? Well, we don't have to freak out about those. All they are, they're not even negative numbers per se. They're just, we want to make them positive exponents by dumping them on the bottom. Right? That would be our deal there going on for those three answers. Okay? So if you notice, we've done multiplying stuff. We've done adding stuff. Have we done division or subtraction yet? I don't think so. So guess what? That's what today is, all right? So hopefully by the end of today, this is our last kind of new piece. We're feeling pretty comfortable with that stuff, all right? So, quotient properties. All right. Abby, can you tell me what quotient means? Yes, I heard you shout it real loud from your seat at home, your comfy chair. It's divided, right? So when we have dividing things, we're going to use the quotient property, all right? I'm going to just jump to the examples real quick. If you're in your notes and want more, you can read stuff. How in the world is Mr. Beak so good at this? Because I'm a math genius. Just kidding. Look at this. How did I get 6 from 8 and 2? Right? I know you're shouting it at home. You subtract them, right? And that's what you do. So whenever you see a quotient, whenever you see dividing with exponents, that means minus. Okay? So right here I had 5 to the 7 minus 3 is 5 to the 4th. Right here, that was maybe the trickiest one for sure. It's negative 3, same base. 6 minus 1 is, of course, 5. Okay? Now, you notice on all of these we have the same base, right? This is the only case that these apply to. And all of these will basically be the same base, right? But if I had like 2 to the 3rd divided by 7 to the, 2nd or whatever, the answer is not something to the 1 power, right? I mean, you just can't simplify that anymore besides getting the real numbers, right? This would be, 8 49s. And that would be your answer, right? So you have to have the same base. That's true with all these. Okay? So, thinking through those, we're just subtracting it. We're going to just hammer through a whole bunch of problems, and then you guys will have a good understanding of this. Okay, first off, if I just said, hey, what you do is you do the top number minus the bottom number, that would look like this, right? That turns into a plus, so this is going to really be 6 to the 16th. Okay? I would not recommend doing that on this one. I like the idea of, I mean, that's the answer, but, and since that's such a mono number, we'll keep it as the answer. I'll just put a box there. What I would do is say, hey, that's a negative exponent. Mr. Beek, yesterday you said you didn't like negative exponents, and what did we do? We brought it up to the top, right? And that's exactly true. So this would end up being 6 to the 9th, and then it's really times 6 to the 7th, right? Because they're both positive exponents now. And so when you add them together, you get 16. That's our final answer. Okay? Really quick and easy on this one. I don't even need a division, do I? It's really going to be 2 to the 4th power, and that's fine. Number 3, I don't like that negative exponent. I'm going to bring it up top. Really, it's going to be 7 to 3 times 7 to 3, which is 7 to the 6. Okay? Hey, this one's going to be negative 7 to the 0, right? That's 5 minus 5. Nothing. Hey, anything, what's anything to the 0 power? Odelia! Any choice? Any guess? It's 1. Nice job. 1 is that answer. Okay? Now, hopefully you kind of thought those, first 4 or 5 were pretty simple, because they are. They're not too much to them. But then you get down to something like number 7, and you're like, oh, what in the world's going on here? Those definitely look tricky. I'm gonna write this bigger so you can all see it a little bit nicer. 3x y to the 4th over 4x to the 3rd. This is the crazy nutso problems that I'm telling you. They might look scary. I don't know. They kind of look scary to me because they're just mono problems. But I actually enjoy these a lot because you look like you're super smart, and all you're really doing is adding and subtracting small numbers, or multiplying and dividing small numbers, right? So what I would do in every one of these, like I said, there's a lot of different ways to do it. So I mean, you can pick your own way. But what I'm going to do is just simplify that chunk first, and then I'll do the second piece after, and then I'll smush them together, right? So is there anything that you can combine on this one? Well, really, I have a 3 and a 4. I have an x and an x cubed, and I have a y, and really you have a y to the nothing, right? So I don't need to write that. I'm going to erase that so you don't get confused, right? Does 3 divided by 4 divide by anything? No. So you just have 3 and a 4. Right here you have x to the 1 on top. I'll just write it out here so you get that little mini problem. And x to the 3 on the bottom. Okay? The new division exponent rule would tell us, hey, we're going to do x to the 1 minus 3, which is negative 2. Okay? And that's the answer. But then I would take that down here and make it 1 over x squared. Right? That's my answer to that one. I kind of like to skip these steps and just instantly go from here down to the right answer. Okay? So how do I do that? Well, I just visualize it. I know you can't see my hand right up here, but there's 1x there, and there's 3 x's on the bottom, right? I mean, that's what that x thing means, right? Where is there more x's? Well, there's more x's on the bottom. How many more? If 1 cancels, it means there's 2 more on the bottom. So I'm going to just dump that on the bottom. Okay? So that's how I would solve this little mini problem. You just visualize, hey, there's 1 up top, there's 3 on the bottom, means there's 2 more on the bottom. Okay? So that's how we solve that one. And then last but not least, this piece, this little y guy right there, he's just sitting there. Okay? Now we're going to times, and we're going to do the same deal with this one. Okay? There's a 12, there's a x, and there's a y. 3 little problems. It's really 12 over 1, right? That's just 12. And then there's an x to the 3, if I'm doing this little problem. X to the 3 and x to the 1. or x to the 2, excuse me. That's x to the 1, because there's 3 up top. 1, 2, 3. And there's 2 on the bottom. 1, 2. And guess what? 2 of those cancel. I'm just left that 1x right there. Okay? And then now we have a y squared just hanging out up on top for that piece. Okay? Over 1. From this point, now we're going to just combine stuff. Okay? Like I said, there's a lot of different right ways to do this. What I would do is I would just multiply the numbers. I would just do all the numbers first. So that's really, it's 3 times 12. We know what 3 times 12 is. Abby, you got that one? Called in you twice today, didn't I? 3 times 12 is 36. And then divided by 4. And then Connor, what do you got? 9? Okay? Then if I'm looking at all my y's and x's and stuff, up on the top I have a y to the 4th and a y squared. Guess what? That's y to the 6th. Now the x is a little bit tricky. It's an x squared and an x. Really, what that looks like is this. Really, what that looks like is this. Where is there more x's? On the bottom. How many more? 1 more. So that guy is on the bottom. And that, ladies and gents, is my final answer. Okay? So these are a little bit tough. Well, I take it back. They're tough looking, because you look at that problem that I just circled and that we just did. Like, that was a lot of steps. But it's a lot of super easy steps, right? I mean, it's just, you know, what's 4 plus 2? It's 6, right? So, I mean, don't try to, like, dumb it down in your mind and don't get too freaked out about it. Okay? Is there any more notes on this one? Oh, there is. Power over quotient property. I'm going to keep working through this because you guys can do this, but oh, this is the same thing. We've already done this. If I had 5x squared y to the 12th to the 3rd power, just so you know, the answer would be bloop, bloop, bloop. It would be 5 to the 3rd x to the 6th y to the 36th, right? And then we'd simplify that down to 125 x to the 6th y to the 36th, right? That would be the answer here. Well, here we just have a division problem. But it's the same exact idea with this distributing going there, and there. And so, real fast and easy. I'll make this one a little bit bigger. It says 2 to the 3rds to the 4th. Okay? The exponent property says this goes there, that goes there. Okay? So what it's going to look like is 2 to the 4th over 3 to the 4th. Okay? And that's all that happens. If you move on to number C or something like that, it's just that 4th, so that one's 3d over 2 all to the 4th power. That goes there, and there. It just goes to each and every piece. So we get 3 to the 4th, d to the 4th, all over 2 to the 4th. Okay? I would simplify those numbers all down, you know, so like, for example, 3 to the 4th is 81. I'll just write my answer right here. 81, d to the 4th. Anybody know what 2 to the 4th is? Lannis, can you help me out on that one? 2 to the 4th power. 2 times 2 times 2 times 2. That's 4 times 4. It is 16. Nice work, Alanis. Thanks for the help. Okay? All right. I feel like I'm talking a lot, and I think the best way to do these is to just practice them. We're gonna spend another day on this. It's not like we're taking the quiz on this tomorrow or anything like that. But I gave you a couple practice problems. They're all here. They start out simpler. So for example, like number 2. That's 7 squared all over 5 squared. Different bases, so that's your final answer. This one's going to be 4 to the 5th over x to the 5th. Final answer. When you get one like number 4, it's going to be y to the negative 2 over 3 to the negative 2. Right? But that's not my final answer, because I want to move that one down, and I also want to move this one up. Okay? That gives me 3 to the squared over y to the squared. which is 9 over y squared. Alright, final answer on that one. That's a little start on your homework there. Hopefully you can figure it out from there. But Google Hangout me. Let me know if you need any help. We're going to eventually get to do ones like that almost all the time. And even some of our homework ones, this is pretty, kind of was a bad photo job on my part there for photocopying, but hopefully you can make light of those and just give them a shot. Okay? I'll be here for any questions. Let me know if you need help. Take care.